In this problem, this is a recursive sequence. They gave you the first ones, and then they told you how to find the next one. That's easy enough. But there's a trick to it because one, there are actually two sequences, A and B. That's fine by itself, but they depend on each other. That is, A depends on what B was, and B depends on what A was. So they're kind of intermixed and tangled, and they want you to find B sub 8, the eighth element, or be ninth, because we're starting from 0 here. So let's see if we can find that. So we know A sub 2 and A sub A sub 0 and B sub 0. They are 2 and 3. This is definition of it. So let's see if we can find A sub 1. What would it take? Well, then n is 0, isn't it? So so 0 plus 1 is 1. And then we have a 0, A sub 0 squared over, kind of messy, over B sub 0 is what I get. What would that be? They told us what they are, so it is a 2 squared over 3. Then what is B sub 1? I need to find it because my A sub 2 and B sub 2 will depend on these values here. So B sub 1, again, n is 0 here, so I would use B sub 0 over A sub 0. But I know what they are. B sub 0 is 3 squared over A sub 0 is 2. Okay, you may think, oh, I'm getting the pattern here. Are you? Let's see. A sub 2 is then what? A sub 2 is, well, it's defined by this, so it's A sub 1 squared over B sub 1. Then again, we know A sub 1, that is this here. So we have 2 to the second power over 3. The whole thing is squared over B sub 1. What is that? That's 3 to the second power over 2. Okay, what about B sub 2? Shall we do this? B sub 0 squared, and that would be B sub 1 squared, is one less number. And underneath, I should have A sub 1. But I know what they are. B sub 1 is this, so 3 squared over 2. The whole thing is squared over A sub 1 is this guy here, 2 squared over 3. Okay, I'm curious what this comes out to. So upstairs is a 2 to the 4th over 3 to the second power. And downstairs is 3 to the second power and 2 to the 1 power, which results in 2 to the 5th over 3 to the 4th. What would I get here? In here, I would get, so I'm dividing line here. Kind of getting messy. Okay, so here I get 3 to the 4th over 2 to the 2nd. I'm saying this becomes that. Over 2 to the 2nd and 3. That would be 3 to the, multiply there, 3 to the 1st power, 3 to the 5th, over 2 to the 4th power. Okay, that's what I got. And can I see some pattern here? It was a 2 power and 5 power. It's too few for me to see here. You can think of it as 2 to the 1 power. But let's see one more, shall we? To see if we can have a better idea of what this is leading to. So A sub 3 would be, again, the definition is this. So A sub 2 squared over B sub 2. What about B sub 3? That would be nothing more than B sub 2 squared over A sub 2. All right. So A sub 2 is this here. So I will use it. So 2 to the 5th over 3 to the 4th. The whole thing squared divided by B sub 2, which is this. 3 to the 5th over 2 to the 4th. Okay, which let me have a dotted line here. Okay, which will result in what? Upstairs would be 2 to the 10th over 3 to the 8th. And then downstairs is 3 to the 5th over 2 to the 4th. What would that give you? That would be 2 to the 14th over 3 to the 13th. Do you see any patterns here? I can go through this. You can go through it yourself. But because I saw the pattern already, All you got to do is switch 2 with 3, then you will get the right answer. So if you see here, if the answer will be 3 to the 14th over 2 to the 13th. But can you see the pattern coming coming up in here? And we are only in 3. You got to go all the way to the 8. How are we going to do this? So let's have a better way of doing this, shall we? This time we will see a pattern in this and do it in a smarter way. The pattern is this. You notice these two here. They are, in a strange way, complementary to each other. It's got a sub n on top, it's got b sub n on top, and this has b sub n on the bottom, a sub n on the bottom. So, out of pure curiosity, let's see what happens if we multiply them. A sub n plus 1 times b sub n plus 1. And what would I get? Well, of course, I would multiply a sub n over b sub n. And b sub n plus 1 is this. They defined it for me, so who am I to argue? I just multiply it. Okay. Well, this cancels, right? And this cancels, and what I get is a sub n, b sub n. To have the full impact of this understanding, let me rewrite this for you. What does this tell you? The product is the same as before. So if you multiply those two, they never change. That's very nice, isn't it? So we will use this fact here to see that it never changed here. So if you go back enough, you will get a sub 0, b sub 0. If you multiply these two equivalent ones, it's always going to be the same. So it's true for these, and we know what they are. It's 2 times 3. They told us. So it's 6. Aha. So, armed with this knowledge, can we rewrite this somehow? Since we want to know b sub 8 here, I would like to rewrite the b sub n plus 1 sequence here and see if I can make an improvement to make my life a little easier. Originally was this, right? Okay, then what kind of improvement can I make? Well, if I know that this a sub n times b sub n is 6 here, then I will just multiply by b sub n and b sub n. All I did was multiply by 1, so this is perfectly legal thing to do. But when I do this here, I know the denominator would become 6. What about the numerator? It would be b sub n to the third power. This is first power, second power, so it's third power. All right, so we made an improvement here. We have this here. If you want to go to the next term, it is just previous term cubed over 6. All right, that's all there is. So shall we go? So now let's start here. So b sub 0 is 3. B sub 1 is what? That guy cubed over 6. So it's 3 cubed over 6. Fine. And then, what about b sub 2? It's this guy cubed over 6. So it's 3 to the third cubed over 6. Okay, let's work this out. I think it will get hairy before you know it. So this is 3 to the 9th power over 6. And then we could break it into 2 and 3. I wonder if it's necessary. I'd like to do that. This is 2 times 3. So it's a 3 to the 9th upstairs. So this cancels here. Becomes 8. So it's a 3 to the 8th over 2 is what I get. So b sub 3, what do? I have to cube it and divide by 6. So 3 to the 8th power over 2 to the 3rd power divided by 6. So that would be 3 to the 24th, 2 to the 3rd divided by 6. So I will just put it here, 2 times 3. So that would be 3 to the 23rd. I canceled with this 3 to the 1 here. And then this becomes 2 to the 4th power. Okay, b to the 4th is what? I think there's got to be an easier way than this, but I started on this, so let me finish it. 2 to the 23 to the 4th power. This number is getting too big. And no, and then 2 to the 4th to the fourth power. Okay, third power. What am I doing? Cubed. So it's third power. So let me just do it right this time. So I got to take the whole guy. 3 to the 23rd over 2 to the 4th, the whole thing to the third power, over 6. I could carry on, but it's getting so hairy. I think there's got to be an easier way. So I will stop here, and this time I will follow the way your book did, that is coming backwards, that is start from b sub 8 and coming down to b sub 0 until you meet somebody you know. Okay, this time we are going to come backwards. So what is b sub 8? The definition tells us it's the previous guy to the third power over 6. So we say it's b to the 7th to the third power over 6. But we know what b sub 7 is. B sub 7 is, I'm talking about only this guy here, in here. Okay, I will write like that. That guy is previous one to the third power over 6. That guy is cubed. This is b sub 7, and I'm cubing it over 6 here. Before we march on, let's figure this one out here. So what is this? You end up getting b sub 6 to the third power, right? So you got 3 times 3 here. So it's better to write it as, you could write it as b to the 6, b sub 6. You can say 3 times 3, or you can say 3 squared. You will see why this is more convenient. And then here you have 6 to the third power that comes in here. And then over 6, which shows up here. Okay, now we got this b sub 6 to the 3 to the second power. All right, now let's move forward. What do we get here then? B sub 6 is b sub 5 to the third power over 6. That whole thing is raised to the 3 to the second power over 6 to the third power times 6. Okay, what is that now? There's a reason I'm not combining this, because you have to see the pattern later here. So let's do this downstairs first. So what would you get? You have 6 to the third to the second power. So you have 6 to the third to the second power times 6 to the third power times 6. That's what's the downstairs. And what about upstairs? We are multiplying these two, right? 3 to the 1 times 3 to the second would be 3 to the third, I hope you see. So it's a b sub 5 and 3 to the third power. Okay, but what is b sub 5 anyway? That is the same as b sub 4 over b sub 4 cubed over 6. Yeah, that's the definition here. But that thing is raised to the 3 to the third power, divided by all these things. 6 cubed squared, 6 cubed, and 6. Let's see what we get. Downstairs we have 6 to the third, 6 to the third to the third. So we have 6 to the third, and here I'm copying these now. 6 third squared, and then 6 third. If you want, I can put it 1. There's nothing here, so there was 1. And what about this guy here? It's 3 to the 0th power. That's 1, so therefore it becomes pure 6. That's how you see the pattern here. And what about this? I have to multiply these two, so this is 3 to the 1 and 3 to the third. When you multiply those numbers here, it ends up being 3 to the 4th power. Okay, now, are you seeing the pattern? Should I go down all the way, or can you see it by now? You know what's going to be for the b to the third. It's going to be, look at the power here. When it was 7, it was 3. When it was 6, it was a 3 to the second power. When it was 5, 3 to the third. 3 to the fourth will be 3 to the fifth. And what would you get here? Everything that you had plus 1 more, which is 6 to the third to the fourth, 6 to the third to the third, 6 third 2, 6 third 1, 6/3 0. That's what you would get. Okay. I think you're seeing the pattern here. Every time this number goes down by 1, the power is going up by 1. You see? When it was 3, it's 3 to the third. When it was 4, 3 to the fourth, 3. So if you add them up, it is 8. You see? So can we have a ... and come up with the b sub 0? We want to get to b sub 0 because we know it. So what would it be? Well, that would be 3 to the 8th. Do you see that? I hope you do. And what about this 6 in the denominator business here? It's growing every time. I had only one of them, and I have 6 to the third, and that to the second power, and then third power. So this power is always 1 less than this number. Do you see? Am I correct? 3 to the third. When it's 5, it's 4, right? When it was 3, it's 2. And when it's 2, it was 1. So here, this number is always 1 less than that. If you don't want to, you're not comfortable with this jumping here, you can go through all the steps and you can still see it. But you see, it becomes 6 to the third to the... This number is 1 less than this number, so I will have 7 here. And 6 to the third to the 6th, 6 to the third to the 5th, 6 to the third to the 4th, 6 to the third to the 3, 6 third second, 6 third 1. If you want, you can say 6 to the third to the 0, or you can just leave it as 6 as it was, you see. Okay, but I prefer to see it as a pattern like that. Okay, now, how can we compute this horrendous stuff? First of all of them are numbers except for this b sub 0 business, but we know what it is. It's 3. So we'll call it 3 because it is. 3 to the 8th. Here, the important thing is the exponent to the exponent. This had to be done first. It has to be clear, actually, who's coming first and who's coming after, because the results are different. But in this case, you have to do the exponent first here. So these two are, the order of operation is that you have to do 3 to the 7th first. So in this case, when you're multiplying all these numbers of the same base, the base is 6, as you know, you add all the exponents. So here it becomes 6 to the sum of all this. You have 3 to the 7th plus 3 to the 6th plus ... and 3 to the 0th. Okay, so that's what you added here. Okay, upstairs is quite easy. 3 to the, what is 3 to the 8th power? I had to do it on the side. It is a 6, 5, 6, 1. Okay, what about adding all these here? Isn't this a simple geometric series? Let me list it for you to make it easier to see. And I will reverse the order as well. I will put the smaller one first. Okay, this is geometric series. How do you add it? It is the first one times 1 minus r to the n over 1 minus r. First term is 1. And 1 minus r to the nth power is 3 to the 8th. Over 1 minus r would be 1 minus ratio is 3. So that's what you get. Would be more convenient if we flip it over. So 3 to the 8th minus 1 over 2 is what we get. 3 to the 8th we just computed is 6, 5, 6, 1. And then if you subtract 1 and then divide by 2, that would be 6, 5, 6, 0 over 2, which gives you 3, 2, 8, 0. Okay, what do we have here? We just computed the exponent of this here. It's kind of being messed up here. I have to separate this part here. So underneath we have 6 to the 3 to 8, 0. Fortunately, we don't have to evaluate all this because they told you to write the answer in this form here. All we need is base of 3 and base of 2. I have base of 6, but which can be easily doctored into 2 and 3. So we have 3 to the 6, 5, 6, 1 over, okay, let's make it into 2 to the 3. Should I show this step here? I think you know. But let me spoon feed in this case. 6 is 2 times 3. Did you know that? Okay, so here we go. 3280. Now you can see it's a 3 to the 6561 over 2 to the 3280 and 3 to the 3280. These two don't mix. 2 has nobody to cancel with, so it will just stay there. It's 2 to the 3280. What about here? They have the same base, so you can subtract them. So when you subtract this number, you get 2 to the 3281. And this is the answer.